Hi, thank you for joining us for this functional safety video for ISO 26262 for automotive. I am Syed Rehan and I'm a senior IoT developer advocate within AWS IoT service team. So let's begin. So in this video, we're going to go through and look at functional safety for automotive. We're going to look at the layers of this functional safety where it applies and how it can be used when we basically build an automotive automobile. Where does it apply? What does it cover? And parts of this is standard. And as always, developer pain points and the summary. So what is ISO 26262 of version 2018? So it has two versions. So the latest version is 2018's version. So it is actually a functional safety is a general approach to make car electronics safe. It is a guideline to protect road users, drivers, pedestrians from injuries caused by faults in vehicles, electronics, and software. We all know latest cars contains modern software and gadgets, right? And gadgets often controlled by software based on IoT sensor, which is the input. For example, a cruise control feature, autonomous driving. Imagine this software failing and causing damage to driver, passenger, and pedestrians. And it could have a very cascading impact on people's life. So for instance, uncontrolled acceleration of the vehicle due to failure of one of these electronics components. Just think about it, right? One simple fault can lead to tragedy, which is where ISO 26262 functional safety comes into effect. ISO 26262 functional safety aims to reduce these risks to a level which is acceptable per human safety criteria standard, i.e. making sure saving humans' life. So as I said, initial standard was released in 2011 and then the latest version is 2018, which is second edition. And it is basically divided in 12 parts of this standard of 2018. And I'm going to talk about what actually ASIL is when we go through in the next screen. So there is a 12 part. So let's go into the second part in the screen and we'll look at it. So we can see here there are 12 parts here for the ISO 26262 2018 version. Part 1, it is actually vocabulary. Vocabulary gives us how to achieve common language and contents of other parts within here, i.e. hazard analysis, safe state, freedom of inference, and so on. Part 2, this functional safety management, which is what number 2 is referring to, gives us how you have to work in a structured and methodical manner to achieve functional safety. You need to ensure you have defined and applied development procedures. You need to have trained functional safety managers. These are the people responsible for planning safety activities. Then you need to create a safety case with why your system is safe. You need to have independent person to confirm your argument and validate it. So let's look at part 3. Part 3 till 7, it basically consists of a V shape of the system development lifecycle. So basically it talks about from early stage, concept stage to product going to end of life. And this early stage of vehicle and feature development is typically performed by car maker. So here we talk about development start by defining the scope in ISO 26262. And this is actually defined as an item, what we refer as an item. Then you need to perform hazard analysis and risk assessment, or in short, which is what we refer to in ISO 26262, HARA, H-A-R-A, which stands for Hazard Analysis and Risk Assessment. It is very important as you analyze risk to human life if your item is faulty. Remember what I mentioned earlier, autonomous car and a failure of a component causing uncontrolled acceleration. Once you have HARA done, you define safety goals for the item. These safety goals are high-level safety requirements which needs to be met, right? And this needs to basically make sure we are on in a page where we are understanding it, that the hazard analysis is done properly, and the rest of the part is basically maintained. We need to look at within it also safety goals. Now, in the previous slide, I mentioned ASIL, right? So So in the previous slide, I mentioned ASIL. So we basically talked about safety goals, and safety goals are high-level safety requirement which needs to be met, right? These safety goals all get ASIL. So let's look at these safety goals, right? We mentioned part 3 to 7 is a V-shape of the system development lifecycle. Now, once you have done HARA, then you basically set safety goals. Safety goals are high-level safety requirements which needs to be met. And then these safety goals, which we have basically set, all get individual ASIL. ASIL is automotive safety integrity level. And ASIL basically varies from degree A to degree D. So if you were to look at, it is actually a risk classification system defined by ISO 26262 standard for the functional safety of road vehicles. So if I were to look at adaptive cruise control, it is actually a defined risk of the highest level. So we give that category or degree ASIL D. ASIL A is defined when the risk is of a low degree. For example, we can talk about electric window, where you could accidentally pinch your finger or hurt your finger. It basically comes in between the window when you're closing it, and that will be a lowest degree of the ASIL. So ASIL accompanies for the rest of the life cycle. It doesn't basically just stays there on between 3 to 7. It goes through each individual level. So in ISO 26262, they are strict rules you have to do and things you are done systematically based on these ASIL risk. So when you are basically going through the system development life cycle, you have to make sure you're making these criteria, giving the safety goals and marking the ASIL category. Now, let's move down into level downwards from 8 and onwards. So we have process level. So in nutshell, remember we had HARA earlier, hazard analysis and risk assessment, which gives us safety goals. These safety goals get ASIL rating, right? And these follow us all the way through the complete to be met across the system development lifecycle, right? Now, as a vehicle level, you must develop, and this is part of a process level, you must develop functional safety concepts, functional safety requirements. What it actually means? What it means is that you can easily detect faulty situation and easily react to these situations. So for example, if I were to say airbag should be deactivated as soon as safety mechanism detects it's no longer working correctly. It's a process. Now, let's look at down further a product level development at system level, right? So here suppliers come into effect and they are basically creating following things. So, namely would be technical safety concept, technical safety requirement. Safety mechanisms are put into place to meet these safety requirements and they are usually interaction between them. For example, you have error detecting hardware, and then you have also error response software. So action performing hardware based on these software responses. For example, hardware has detected an error and error has been detected by software. And then it can be resolved by soft reset. So the software can do a soft reset. Taking these instructions, hardware can re-energize the circuit to make sure that we can eliminate this error which was popped up. So similar to like a soft reset or soft reboot, and without causing cascading impact. Knowing that because we had defined this as part of the HARA and defined it as ASIL, it is low degree. We can basically meet the safety concept by making sure the error detected by hardware could be for any reasons, and software detects it, resets it, and gets on going with it. Then we have part 5 and 6. Now, part 5 and 6, we are talking about hardware and software, which is actually a product development. So in part 4, of the section within the V diagram, we looked at system level, right? These needs to be implemented at hardware and system level. In here, we look at safety requirements, which is in part 5 and 6. We look at safety requirements from both hardware and software development domains. We can see V model here, so we don't forget to test all levels. So we need to make sure, the domains or the engineers, the organizations, the departments, within hardware and software are working tight, making sure that they're not forgetting to make sure test every individual level to meet the criteria. They need to make sure they're testing and validating safety mechanism. And then you also need to make sure the functioning of your safety concept at system and vehicle level. This needs to be done before we can switch on any assembly line. And that is actually a key differentiator and basically an aspect of ISO 26262, because you are not allowed, unless you have met the criteria above or other parts earlier, you won't be allowed to switch on assembly line. Now, let's move it forward and go into part 9, where we're talking about safety analysis. So let's just recap before I go into part 9. At level 9, which is a system level, level 5 and 6, which are software and hardware level, and these needs to be met to meet ISO 26262 standard. Now, let's look at part 9, where we need to make sure safety analysis needs to be carried out in parallel to the development to understand few things, such as causes, effects of fault, and how to safeguard the design. Okay, now I'm circling back because I went to 9, then I'm going to go back to 7 and 8, right? So 7 and 8, because we have a V line and we have to make sure that we are going through the process, and this is the process when software system development's life cycle. So part 7, keeping in line with ISO 26262 standard, we need to be held responsible at production level. We need to be responsible for operation, we need to be responsible for service and decommissioning. For example, we need to check if electronics were produced correctly, they were installed safely, and the repairs in workshop must not carry any safety risks. For example, the product has gone out, the vehicle has been gone out, and we have done analysis that if somebody is basically carrying out repair in workshop, they're not carrying any safety risk against them. People are doing it. We also have something called field observation process. This is where we examine defective parts. So detect potential deviation from decided safety concept in earlier parts, and if so, whether we can update software, firmware, or replace hardware to meet the ISO 262 standard. And this is where we decide in part 7. Now, let's go into part 8, supporting process here. This contains wide variety of topics to align with various life cycles. For example, this is where we're talking about configuration management, and this is where we're looking at supporting the process as part of it. Part 10. Part 10 is basically a guideline. Guideline part is there for informational purposes to make sure we are adhering to these guidelines throughout the process. Now, let's look at the part 11. Semiconductors. Semiconductors contains guidelines in details such as selection and usage of a microcontroller unit in safety related system. Example would be a car ECU, because we need to make sure these components are meeting the criteria, hence the selection criteria for semiconductors. Part 12. This part has been specifically added and dedicated for motorcycle sections. It gives details, information on how to carry out HARA, which is, as we know, has an analysis and risk assessment is specifically designed for bikes. So there we have it. So let's move on and look at recapping it. So some of the things when I speak to developers, and I often hear from them, is that there is a disjoint between hardware engineers and software engineers. And this purpose of ISO 26262 is to align it and bring it together. So there is a holistic harmony between product development domains and organizations and engineers. You need to make sure some of the pain points they basically align to is adhering to V model. And this is where the process we talked about earlier as part of so this is a process we talked about earlier, ISO 26262 of those 12 level. In terms of supporting process, the guideline process will make sure that you're adhering to the V model. You also will basically eliminate the disjoint development process by having the system level mapping. So you need to make sure you're correctly mapping concepts between levels. So when you're basically talking about building a product, system development product, you need to map it individually based on your organization way of developing it. But you need to adhere to the V model. You also need to basically set up guidelines, the processes, and individuals who are basically can audit that you have set up error detection setup, you have detected and set up processes for responses and mitigation of those error detection. Remember we talked about earlier of having a hardware detecting error, then software detecting that error, and software realizing that if this can be resolved by just creating a soft reset. This is where we're talking about error detection, response, and mitigation. And then you need to basically align this with the whole supporting process. This is where one of the process of ISO 26262 tell us and guide us that you need to make sure that you're adhering to the process as we saw earlier in part 8. Now, safeguarding functional safety with 12 parts, it is pivotal that when you're basically adhering to ISO 26262 that you're following this with extreme rigidity. You need to make sure that you're not deviating from it, and that's why there's 12 parts. Now, in summary, why does ISO 26262 exist? We talked about it, why it exists, and what was the purpose behind it. Because obviously it's to safeguard humans' life upon any electronic failure. We talked about HARA, hazard analysis, and then we said the HARA output is actually ASIL, right? And the ASIL being automotive safety integrity level. They range from A, B, C, D. A being the lowest and D being the highest risk. And then we also talked about mapping this ASIL steps and efforts with the safety goals which we create in our HARA. And then we also talking about this is standards designed to be consumed and validate for automotive organizations and manufacturers. And the purpose of this design is from early design to production leading to vehicles end of life. For example, you're creating a design of a product, you're building the product, and this process follows us through all the way until the vehicle reaches end of life or end of production. And we need to make sure we're adhering to it. So there we have it. This was ISO 26262 in short. If you have any questions, please don't hesitate to reach out to us directly. You can reach out to us on IoT Builders YouTube channel. You can basically scan this QR code, reach out to me on Twitter or LinkedIn. I'm always happy to help. And with that, hope you enjoyed this. I've also included a link for the official information where you can basically go ahead and get ISO 26262 version 2018 official link and read it. I have basically incorporated all this for you just to make sure you get a quick snippet and run down what is ISO 26262 is of version 2018. I hope you enjoyed it. If you have any questions, always happy to help. Otherwise, have a great day and reach out to us for any more questions. Goodbye.